In the last video, we worked on the feature where the agent can navigate toward the member and cause damage, but it only works when you're the leader. Let's investigate why that happens. So we have an agent manager who is calculating everyone's movements. This is actually only happening on the leader. Then it's sending agent movements. And here, if there are agents, it will iterate through all of the active agents. It means all those that are moving, that are not moving, calculate the new positions, send them over there. And so this seems all fine. Oh, yes, in the constructor, we set upon the crowd a callback. That means on reach target observable. Emit this thing. Now, why does this only happen on the leader, though? Or was I mistaken? This should happen for everybody, no? Let's read it. So we get this callback, given some agent info, every time a agent moves upon its target. Here we get the agent index from that information, and then we're going to go through and look through the agents, looking for the agent name. And we say got there, so it's moving is false. And then we say how close it is. Oh, okay, because the proximity is only calculating based on the camera's position to your... Well, this should be fine too. So if the agent is upon me, that's my active camera, then I should get the damage. So I won't dish out damage for anybody else. So this should also be running on the client, their client as well. So why don't we just do a console log of proximity and tell us what the proximity is. And we'll open up two browsers. So we'll let Chrome be the first browser. And I'm moving off the navigation, so the agent that is created won't be able to come to me. And so I don't think I will receive any damage here. Let's see in the console. So it is calling the callback. It is getting to a certain target randomly. Now we'll copy this and we'll open up Firefox. This will go on the right side here. Paste that in. Whoops. Wait. What I'm looking for is that, okay, so I think he's seen me. No, okay, he's seen me. Maybe not. He hasn't seen me yet. He isn't even coming toward me. Well, the coming toward me calculation is probably not that great. It only executes every time it's finished moving. And now they're stuck. I think one of them is indeed stuck. Okay, now they're unstuck. I'm waiting for it to come toward me. Let me just get in the sight of this person. He might be stuck on a space he can't move. Whoops. So now I'm under the floor. Okay, here's proximity. 1.4, but I don't think we're getting... Is it going to come toward me again? It's coming toward me, but we're not getting damaged. Why? Let's look at this. If proximity is less than 1, which it isn't, it's always like 1 point something. So did it have to be less than 2? Okay, so this is the leader. So maybe that's what it was. It was the proximity calculation. Alright, we have somebody coming toward us, and he's going to land on top of us. Okay, now we're getting damaged. I see it now. Okay. Alright, so that's what it was. It wasn't a... It was a threshold issue. So we can close this, and I can close this. But I guess let's kind of redo their calculation a little bit. And okay, so I guess this is fine. I would like this to be a little bit closer. I just don't know why it stops there. It's maybe because he's a little bit above the ground. Anyway, let's go to the part where we're doing this part. So this agent movements, we're going to calculate. And I guess we want to calculate for everybody, not just the people that are headed toward a place. Because you might see an agent. So let's see, first you grab all the agents, and here we're filtering by all the ones that are moving. But actually I think you could do the calculations for everyone. But if you're getting a random... Okay, so you're getting a next position. Okay, which is either you see them or you don't see them. So let's split this out for the next position. You have the current position. You have const C avatar at this Oops, didn't copy this correctly. Copy and paste. Or random position, which is this. That's why we could be 2 meters away. We're getting a random position. No, that's not true. This is... Okay, the closest position might be... What's the deal with this? Implicitly has any type... Okay. Oh, sorry. Just a sign. or random position within 2 meters. And then you have a constant delay. So here we get name is this, current position is this, and then we'll pass in C avatar at and random position here. So we're just passing them all along. And so if this is null, we have to calculate this. If this is not null, we don't have to calculate this. So we can say C avatar at or this, which will short circuit this. So if this is nothing, undefined or null, it has to calculate this. Otherwise, it will just be the same as this because we won't use it. Coming over here, if you do see the avatar, make that your next position. Otherwise, we want to know if you're moving. Okay, so only calculate. Okay, so if this is null, actually, I guess it doesn't matter if we see them. If we see them, that's the next position. If we see them, that's their next position. If you don't see them, and if they're not moving, okay, so let's not. Okay, so then you'll use if agent moving is false. Agent moving if agent moving equals false, then we want to calculate. If agent moving is true, we're going to leave it alone. Well, why don't you just calculate this in the next one? Why make it this confusing here? So I want to filter again by all the agents that, so first you get all the agents that can see somebody. This will either be C avatar at or it's null. So we don't have random position here. And we don't need the delay yet. Paste those here. Then we want to filter, keeping only those that see avatars or the agent is moving. So let's just pass the agent in. And we don't need the current position yet. Don't need this yet. I don't even need the name yet. But yeah, we'll pass that along, sure. Okay, so we want to filter. So we're getting a payload with deconstruct. We get the name, C, avatar, at, and agent. We want to return true for anything where agent is moving false, or C avatar at not equal to null. And this closest point to scene agent returns null if you can't get something. So if you see something, then you're going to keep it, or hit stop moving and you want to give it a new position. So then everything that's coming through here is still this payload. Let's use this here. Then, okay, current position becomes this. Random position becomes okay, so now we need to calculate next position. So const next position equals, so if agent is if there's C avatar at set, then return C avatar at, otherwise give me a random point around current position, give me a random delay, and the name will be this name, previous position will be current position, next position will be this next position, and delay will be this delay. So that should help the agent spot us faster, because we're calculating it minimum once per second. It's just that if they don't see us, they won't get updated. We need to filter out those that didn't come through, right? So we're filtering out. This might agent moving false, or you don't see them, which means you might not have an operation here. So then that gives you future positions. So this whole thing is called future positions, but you could just, yeah, it'll return if there's no future positions. Okay, so if we test this, at least the performance for the site will be able to. So as soon as it makes this context scans over us, he's going to come straight for us. I'm coming over here. He didn't see us anymore, but he's going straight for there. I'm going to come over here. Oh, we're getting damaged. Okay, over here. I think they see us. Damage, damage. I'm going to come over here. Oops, sees us. Okay, so it's a lot better at finding us now. Okay. I would consider that bug not a real bug, it was something else. This was not true. It's just that the proximity was too far away. It was what? It was like 2 This was kind of too far away. So we'll leave it like that. Let's remove some comments. Some cleanup. Okay, so we have a primitive working agents that can attack you.